Greetings to Dr. Rackford Bong and to all of you who are watching our video presentation on our mini project of steel structure and design. My name is Dodi Paslimiki and my number cut metric is 07DKA18F2005. So first and foremost, we thank the Almighty God for being us and guiding heights of success. The industrialized training that we underwent at steel structure design provided us with a very valuable exposure to the construction industry and helped us to understand the various techniques that we learned. We wish to express our gratitude and indebtedness to Dr. Rackford Bong of Lecturer Steel Structure and Design for his generosity and willingness to teaching and expertise with us. Also, we take this opportunity to thank all the department members of the Department of Civil Engineering and friends for their help, advice, and suggestions which contributed either directly or indirectly for this work.
Hi, my name is Marlene Melanie Masilu Simon and my matrix number is 07DKA18F2039. For introduction, Mini project is an important component in the development of the practical and professional skills required by an engineer. The purpose of the mini project is to achieve exposure on the practical engineering side. The fundamental objective of mini project is to prepare students for the future employment in their chosen engineering discipline. Mini project enhances the academic material studied at college by allowing students to practice what they have learned and to develop key professional attributes. Detailed planning of the structure usually comes from several studies made by town planners, investors, users, architects, and other engineers. On that, a structural engineer has the main influence on the overall structural design and an architect is involved in aesthetic details. The aims of mini project is to done the structural analysis and design of the structure by using AutoCAD.
Hi, I'm Elistela Alisus, metric number 07DKA18F2008. For abstract, as a several years in industrial training was done by analysis and design of single-story building under the guidance of Dr. Rackford Bong. The design of single-story building is one of the leading steel structural design. They undertake wide range of reinforced concrete structure. This mini project was oriented toward assisting we to obtain hands-on experience of this design and construction industry. This work was completed in 5 stages. First stage was analysis the beam in restrained and unrestrained beam. For the second stage is connection for design of bolt. The third stage was the column for the analysis. And number 4 was the analysis of the truss to compression and tension member. And the final stage was the detailing of different structural components. The structure was analyzed in notes that's given also by the Eurocode, and the design of the structural component were done by manually. For the detailing, works were done in AutoCAD.
Assalamualaikum, nama saya Nur Izatul Afifi binti Ramli dan nombor kat metrik saya adalah 07 DKA 18F2014. For scope and objective of the mini project, our main objective include for getting the basic knowledge of construction of single-story building. Next, to practicing and experiencing the planning, designing, and field study of the construction project. Next, awareness of building rules. Next, change of getting the idea about construction equipment, construction method, and technique. Next, study about beam, connection, bolt, column, and trusses. And the last is using the software package such as AutoCAD for designing and analysis of building. Pada hari ini saya akan membentangkan tentang beam. Jika Anda lihat di atas ni adalah diagram roof structural layout plan. Beam yang kami kira adalah beam AB dan beam AD, dan terdapat satu secondary beam di antara beam AD. Dan saiz yang kami guna untuk beam AB dan AD adalah 610 darab 229 darab 101 UKB S275 steel. Sebelum itu, kami akan mengira dulu load on slab untuk mencari QK dan GK yang sebenar. Load on slab ini adalah specification dia. Long span iaitu LY, kami punya LY ialah 10,000 mm. Short span LX iaitu 4,000 mm. Itu LY bahagi LX kami mendapat 2.50, lebih besar daripada 2.0, dan ianya adalah one way slab. Seterusnya bagi slab thickness. Slab thickness, minimum thickness for fire resistant kami adalah 100 mm. Estimate thickness considering deflection control iaitu H 4000 bahagi dengan 35 kami mendapat 114 mm, dan kami menggunakan H sama dengan 150 mm. Seterusnya ialah bahagian action. Action slab weight kami ialah 0.15 darab 25 dan kami mendapat 3.75. Permanent load excluding slab weight 1.0, dan karakteristik permanent action GK kami mendapat 4.75. Karakteristik variable action QK 0.10, dan hasil action ND kami mendapat daripada 1.35 GK tambah 1.5 QK kami mendapat 6.563 kilonewton per m02. Beam yang pertama kami kira ialah beam AB. Permanent load GK yang kami guna ialah 4.75 kilonewton m02 excluding safe weight. Variable load QK ialah 0.10 kilonewton per m02. Design data, kami menggunakan design data daripada size yang kami guna, iaitu saiz kami ialah 610 darab 229 darab 101 UKB S275. Design data ni daripada Euro Code 3. Seterusnya kami ada membuat analisis. Design load, ini adalah design load. Design load W sama dengan 1.35 GK tambah 1.5 QK, kami mendapat 6.563 kilonewton per meter. Itu kami ada mengira MED. MED bagi beam AB yang pertama ialah 82.04 kilonewton meter, dan VED ialah 32.82 kilonewton. Untuk beam AB, flange dan web adalah dalam kelas pertama. Oleh itu, keseluruhan cross section classification dalam kelas pertama. Bending resistance of cross section pula hasil dikira iaitu MCYRD 792 kilonewton meter, dan dibezakan dengan MED kami 82.04 kilonewton per meter, maka MCYRD adalah lebih besar daripada MED kami, maka ianya adalah okey. Seterusnya shear resistance. Hasil di pengiraan ini kami mendapati bahawa perbezaan antara VED kami dengan VCRD kami mendapat 1063 kilonewton dan VED kami mendapat 32.82 kilonewton, maka VCRD adalah lebih besar daripada VED kami, maka ianya adalah okey. Dan bagi deflection untuk beam AB, hasil daripada pengiraan kami, beam kami mendapati bahawa beam size 610229 darab 101 UKB adalah satisfactory. Jika anda lihat di atas ni adalah diagram roof structural layout plan, dan pada bahagian beam AD ialah terdapat ada secondary beam di antara beam AD iaitu A1, dan antara beam A hingga A1 adalah one way slab. Oleh itu faktor dia ialah 0.5, dan manakala 1A hingga D ialah tidak mempunyai slab. Untuk mencari point load di beam AD, kami akan menggunakan AB. Oleh itu, ND sama dengan 6.563 kilonewton per m02. W sama dengan ND darab LY, iaitu 6.563 darab 10 mendapat 65.63 kN per meter. Darab dengan faktor, oleh kerana faktor dia one way slab, kami menggunakan 0.5, iaitu mendapat 32.82. Bagi P1, 32.82 darab 10 bahagi 2, maka point load ialah 164.10 kN. Seterusnya, ini adalah untuk mencari reaction, iaitu dy, ay dan ax. Bagi bagi dy, iaitu kami mendapat 65.64 kN. Bagi ay, kami mendapat 98.46 kN dan ax ialah kosong. Seterusnya, ini adalah gambar raja, shear force diagram dan bending moment diagram berdasarkan daripada beam AD. Yang pertama, shear force diagram, kami mendapat 98.46, seterusnya 32.82 dan seterusnya dan terakhir 65.64. Bagi bending moment diagram, kami mendapat hasil daripada pengiraan bending moment diagram BMD, iaitu 393.84. Untuk BMD, kami menggunakan saiz yang sama, iaitu 610 darab 229 darab 101 UKB. Dan bagi beam AD punya flange dan web adalah dalam kelas pertama juga, dan itu section kelas pertama. Dan bagi bending resistance of cross section, hasil pengiraan kami dapat 792 kN per meter, lebih besar daripada kami punya bending moment, iaitu 393.84 kN meter. Oleh itu cross section resistance dalam bending kami adalah okey. Seterusnya, lateral torsional buckling check pada segmen AD. Dan bagi untuk for end moment loading C1, kami C1 kami mendapat 1.88, iaitu lebih kecil daripada 2.75. Dan MCR kami mendapat 1125 kN per meter. Dan non-dimensional lateral torsional slenderness for segment AD, XLT kami mendapat 0.84. Dan untuk select buckling curve and perfection factor daripada table 6.64, hasil daripada H bahagi dengan B, iaitu 602.6 bahagi dengan 227.6, kami mendapat 2.65. Oleh itu for roll 1 section dengan H bahagi B lebih besar daripada 2. Oleh itu kena menggunakan buckling curve B. Seterusnya lah determine imperfection factor. Untuk buckling curve B, ALT adalah sama dengan 0.34. Seterusnya ialah buckling reduction factor XLT. XLT kami mendapat 0.70, lebih kecil daripada 1.0. Seterusnya ialah design buckling resistance. Hasil daripada MED bahagi dengan MBRD 393.84 bahagi dengan 554.0, kami mendapat 0.71, lebih kecil daripada 1.0. Oleh itu segmen AD adalah okey.
So, in this presentation, I'll be going to explain my part in column for the calculation, in column for steel structure and design. So as you can see here on beam 1AB, we got our design load, which is 6.56 kN per meter, and we use it to times with Ly, which is the length of the beam, which is 10 meter, and times it with the factor of load, which is 0.5, and we got our load for the beam on AB is 32.8 kN per meter. And for our moment, we calculated it by using 32.8 times with 10 and times with 5, and minus with by times with 10, and the answer that we get is for by is 164 kN per meter. While for the vertical load on AY is by AY minus with 164 and equals to 32.8. 32.8 is the load on the beam. So therefore, we got our calculation by using it for the AY is 131.2 kN. While for beam 1AD, we got our calculation for the P1. P1 is 164 kN, and for our moment is By on moment on the dy, my bad, is 65.6 kilonewton. And for our vertical load is for AY vertical load on AD beam is 98.4 kilonewton. So for our analysis force or loads, as you can see here, the total compression load, which is our NED, is 238.97 kilonewton. While for our bending moment due to eccentricity at moment on level 1, M prime Y ED is 33.75 kilonewton, and our M prime Z ED is 1.04 kilonewton per meter, and our MY ED is also 33.75 kilonewton, and our MZ ED is 1.04 kilonewton per meter. So as you can see here, this is our design of column with nominal moment in simple construction with our size of 203 times 203 times 46. Okay, so our design of strength, as you can see here, is Fy equals to 275 Newton per millimeter, and our cross-section classification, as you can see here, the 0.92, and according to our calculation here, therefore our overall cross-section classification is class 1. And our minimum buckling resistance, as you can see here. Okay, so this is our calculation, and we've been doing this according to the formula that was given. And this is the same one also on buckling about minor axis on ZZ. And for the lateral torsional buckling resistance, as you can see here, this is our calculation that was made by us according to the formula that was given by our lecturer. Okay, so the MCR is 397.5 kilonewton per millimeter, and this is the calculation for the LT is 0.65. Okay, therefore for the reduction factor for XLT for LTB, as you can see here, XLT is 0.95, and for the lateral torsional buckling resistance is 129.84 kilonewton per meter. While for the section resistance, as you can see here, the interaction equation for the final question in this part of this question, our answer is 0.65, and therefore the section size 203 times 203 times 46 you can see is satisfactory.
So in this slide, I will explain about the connection, design of bolt. The solution for the analysis of external forces, detail of holes and bolt adalah D 24 mm, E1 50 mm, P1 is 100 mm, and DR is 26 mm. The direct shear Fs in bolt A, Fs is 21 kilonewton, and the shear due to torsion Ft in bolt A adalah 43.2 kilonewton. Untuk resultant of shear, Fr in bolt A adalah 53.6 kilonewton, and FVED equal to Fr, so equal to 53.6 kilonewton. The design of resistance against external forces, we tried 24 mm bolt, hence the D is 24 mm. The hole diameter DO is 26 mm, and the shear resistance of one bolt FVRD equal to 67.78 kilonewton. For the bearing resistance per plane, FVRD is 264.2 kilonewton. Since the FVED equal to 53.6 kilonewton is less than FVRD equal to 67.78 kilonewton, so the amount is 264.2 kilonewton. Therefore, 24 mm diameter of the bolt of grade 4.6 is satisfactory for the connection.
Hai, dan saya akan menerangkan bahagian roof trusses tension member. Solution dia ialah end member connected with 2 bolts, and first tension force NED dia ialah 21.5 kN, and for tension capacity tri-unequal angle is 150 times 75 times 10L. Ini kita boleh dapat dari steel building design data. Design strength dia, T dia kami dapat 10 mm, iaitu kurang daripada 40 mm, dan steel grade dia kami dapat S275, dan bagi FY kami dapat 275 dan FU kami dapat 430. Selepas itu, kami masukkan semua data dan calculation dia and check nilai dia mesti kurang daripada 1.0, dan nilai yang kami dapat iaitu 0.04 kurang daripada 1.0, which mean section 150 times 75 times 10L is suitable to carry tension. Dan untuk design plastic resistance of the cross section, kami dapat 596.8 kN, dan juga pengiraan untuk the design ultimate resistance of the net cross section at holes for fastener, kami dapat nilai 671.8, dan kami cek nilainya juga mesti kurang dari 1.0. So, nilai yang kami dapat ialah 0.03, which mean kurang daripada 1.0. So, section 150 times 75 times 10L is suitable to carry tension. Dan di sini untuk compression. Untuk axial compression, NED kami dapat 43 kN, dan tension capacity tri-unequal angle is 150 times 75 times 10L. So, data ini kami dapat juga macam yang tadi, boleh dapat daripada steel building design data. Dan bagi yang classification of cross section, kami dapat ialah section is class 3 and not susceptible for local buckling. Selepas itu, semua pengiraan yang kami dapat ialah semua dari rujukan atau contoh calculation dari SIDOS. And lastly, nilai adalah mesti kurang daripada 1.0. So, nilai yang kami dapat ialah 0.72 dan ia kurang daripada 1.0, which mean section 150 times 75 times 10L is suitable to carry the compression force. Thank you.
Therefore, as you can see here, in our conclusion, the beam size 610 times 229 times 101 UKB is satisfactory, while the column section size for 203 times 203 times 46 UKC is satisfactory. Therefore, 24mm diameter of bolt of grade 4.6 is satisfactory for the connection. Lastly, for roof truss, section 150 times 72 times 10L is suitable to carry the compression force. And as you can see here, this is our AutoCAD design for steel structure and design that was made by us according to the rules of this. And as you can see here, this is our AutoCAD design for the structural of steel structure and design. Okay, so this is our AutoCAD design that was made by us, and according to the detailing that was given here, and it was the first one for the column, and the second one is for the beam, and the third one is for the bolt, my bad, and also the last one is for the roof truss. Okay, and that's all for me and my team today, and thank you to Dr. Rackford Bong.